you. The first topic, which, as I told you before, I will start from now up to 10, is about the introduction to waves. And I want to present you some details about the shapes and the property of waves. And after that, we will start with ultrasound definition, application, basics, and uses of ultrasound in medicine for diagnostic imaging and for treatment. Okay, so as I told you, first of all, I want to tell you something about the definition of waves. Please look at my slides, which I can see myself, but I don't know about you. I asked some students and they told me they can see my slides. And if you go a little bit furthermore, you will see two or three slides in person. Please don't worry about them because if you focus on my slides, I wrote them by hand. So just for more focus on them. But you can be sure that I will explain everything in very simple words and very in more details. And also, for example, for Persian slides, I have the English slides too. Just I will try to explain everything in a very simple way. Okay, so don't worry about that Persian slides. First, I will start with the second slide. And also, for example, my first slide is in person, but it's right just I try to show that waves. So this is just one word in these slides, waves. Now, why waves is very important for me and why I have a lot of things about waves. So please let me go to a little bit further first to this slide number 6. Can you see slide number 6? Please let me know. Thank you very much. Sorry, because I cannot see you directly, so I need sometimes to ask you for confirmation because I want just to be sure everything is okay, the internet, the connection, and everything. So, why I want to return back you to high school? Why today I want to confuse you by some basic of physics or physics phenomena? Because you know that in medicine we have a very important component in our body which we called it the cell. And you know better than me that all the cell is covered by a wall, by a protective wall. This wall is made of two layers of lipids. You will see on slide number 6 on corner at up at the left corner at up, the cell membrane or the cell wall is made of two layers of lipids. Each lipid molecule, it has a two component head, which is it's like water and we call it hydrophilic head, and the tail, which the tail don't like water but it's like lipid, and we call it hydrophobic tail. So each cell membrane made of two layer of lipids, and if you look at this cell membrane on top by electron microscope, you will see something like the figure that I showed in slide number 6 on the corner on top, on the right on top. And you will see if you look at the lipid head by microscopic electronic, you will see something like this: several spherical shapes which attach together, but actually they are not completely attached together. We can see some gap, we can see some free space between them. Can you see that? On the head of lipids, if you look at them and if you focus, you will see some gap. So my goal is present you the waves that, or the kind of waves that is smaller than this gap, and they can go inside the cell. So we are looking to find which kind of waves is smaller than this gap and can entrance into the cell, or can penetrate inside the cell and damage to the critical component inside the cell like DNA. So my goal of this first class from this morning is introduce you which types of waves have a shorter wavelengths or are smaller than this gap, and they can go inside the cell and damage to the cell. Okay, is that clear for you? So thank you very much. So I can return back and explain you, and finally I will tell you which kind of waves can pass through this space, this gap. Okay? Return back to the slide number 2. Yeah. This is a general shape for waves. You know from high school, from elementary school, from basics courses in physics, that we are made of waves. All of peoples, all of plants, all of animals is made of waves. Why we believe that? Because we have two types of waves in the world: mechanical waves and electromagnetic waves. So please memorize that we have two types of waves: electromagnetic and mechanical waves. And I try to explain them in the Persian slides, which I will go that a little bit. Yeah, here it's slide number 3. On the top of these slides, I just wrote in Persian waves divided in two categories. The first category is mechanical wave, and the second category is electromagnetic waves. And then I will start with the origin of these two types of waves. How we know that we have a mechanical or electromagnetic waves, but before that we should know that where they come from, the mechanical wave and electromagnetic wave. So the origin for mechanical waves is vibration of atoms. So please listen to me. Vibration of atoms can create mechanical waves. It means that if you try to move the atoms like a spring and then vibrate the atom, this atom can vibrate their neighbors, and we have mechanical waves. So the origin for mechanical waves is vibration of atoms. For example, sound. When I'm talking with you now, the words can come out from my mouth, and they can trigger a specific tools or specific electronic tools which we call microphone. The microphone convert the sound, which is mechanical wave, to electrical wave, and in the other way you can hear my sound. Okay, so the sound is a simplest example of mechanical waves. And you know from high school, the mechanical waves for propagation in the space, they need medium, because as I told you, the origin of mechanical waves is vibration of atoms. So we need a medium for propagation of the mechanical waves. For this reason, mechanical waves are very sensitive to the medium properties. So their velocity or their property is depends on the situation and condition of the medium. For example, the pressure of air, the humidity of air, the I don't know, the the temperature of the air. All these situations can affecting to the velocity of mechanical waves. For example, ultrasound or sound, which they are mechanical waves, their velocity is depending on the situations. And the second category, which I wrote on the bottom, it's electromagnetic waves. Again, the question is where this come from. The origin for electromagnetic waves is movement of charged particle. Please pay attention to these three words: moving charged particles. So it means that if you want to make an electromagnetic wave, you need a particle who have a charged, okay? You need a particles who have a charge, or you need some specific particle with a charge. And this particle which is charged should be moving. If it's not moving, you don't have electromagnetic wave. And you know again from high school that all the, I don't know, people, all the animal, or all the medium made of specific things which we called it molecule. And also the molecule is made of atoms, and atoms itself made of three important parts: electron with negative charge, proton with positive charge, and neutron which it doesn't have charge. So we know that for creation of electromagnetic waves, neutron cannot be included because they don't have charge. Just the electromagnetic waves can created by electrons or protons because they have charged. Now, the most important thing is if you can try to move or to push proton, you can create electromagnetic wave, or try to move electron, you can create electromagnetic wave. The mass of proton is too, uh, I mean that it's very heavier than electron. So moving the proton is, imagine it's like a basketball ball compared to ping pong ball, which it's very small. It's very, it's very light. So moving the electron is very easy, but movement of proton is very difficult. So we can say that in simple words, the origin of electromagnetic waves is just moving the electron. So the source of electromagnetic wave in the world is electron. And as you know that we have, or all of us made of electrons, so we can say all of us are made of electromagnetic waves. For this reason, the source of electromagnetic waves is just electron. And if you look at the two simple figure that I draw by my hand in this slide number 3, you will see in physics we have a very simple phenomena which we can show that the moving or the repeatable movement. In these types of movement, we can create waves. But for knowing the waves, we should know that all of us, for example, me and you and the other students, we have an ID card. In this ID card, you have first name, last name, father name, ID number, or I don't know, the date of birth and the place of birth, and etc. So all these specifics help to make a distinguish between us. You know that sometimes we have some students with the same first name, and for distinguish them we will go to look at their last name, or we will go to look at their birth date of birth, or their father name, or something like that. So all the electromagnetic and mechanical waves also have ID card. And in their ID cards, two properties very important for me. Suppose that it's like a first name and last name, but in case of waves, These two property is frequency and wavelengths. So please note that these two types of property is very important for me. The first one is frequency and the second one is wavelengths. Just a little bit go back to slide number 2. In slide number 2, I show you a better figure than that I wrote in the slide number 3 for waves. You will see in a red curve shows the simple shapes of the world. Excuse me, simple shapes of the waves. And in this shape, in this figure, you will see waves should be repeatable. It means that each point should be repeated. And if it stop, it's not a wave. So the waves, it means repeating continuously. Okay. So in this repetition, the distance between each two same point called wavelengths. For example, in this figure, the distance between two peaks or two, I don't know, to the same periodic time points is called wavelengths. For example, the simplest way is to understand the wavelengths. Look, if we have a bump and this bump repeated again, the distance between these two maximum point or these two bump is called wavelengths. And the number of the bumps which you can see in 1 second, we called it frequency. So we shows the frequency by f, and we show the wavelengths by a Greek letter which we called it lambda. And lambda it's like a y but it's inverse. Okay, so for measuring the wavelengths and frequency in standard international system, we used meter for measuring the wavelengths. So when I tell you that we have a waves with wavelengths of 2 kilometer, it means that one point is here, the other point is 2 kilometer far away. Or when I tell you we have a ultrasound wavelengths which we want to use it for imaging of liver, and the wavelength is 2 micrometer, it means that one of the point is here, the other point is just 2 plus 10 to minus 6 meter away. 2 micrometer is it's very short wavelengths. Okay, but in case of frequency, we use hertz for measuring. What is the frequency actually? If I asked one of your students to stay on the top of the wavelengths, and if I give you a chronometer and I ask you to just count the number of peak will pass through from against or in front of your eyes, the number of peak per second, we called it frequency. For example, if I told you this wave it has a frequency of 2000, it means that in 1 second you will see 2000 peak pass through in front of your eyes, and we call this 2000 hertz. So the main quantity which we can measure frequency, it's called hertz. And sometimes hertz is very small, so we normally used kilohertz, which it means thousand of hertz, or megahertz, which it means million of hertz. So if I tell you we have a waves with frequency of 6 megahertz, it means 6 million hertz. It means 6 million peak per second. Okay, so this two property was very important in the waves ID card, and we should know them. Return back to slide number 3. Again, in the top of the page, I wrote a very important relationship between frequency and wavelengths, and please try to learn it. Frequency and wavelengths relationship are inverse. It means that if frequency increased, the wavelengths will be decreased. And if the wavelengths increase, the frequency will be decreased. Okay? Is it clear up to now? Or if you have any questions, you can type here and I will answer you. Okay, so Up to now, in this during this 15 minutes, just we learned that we have two types of waves in the world: mechanical waves and electromagnetic waves. They they have a very important property: frequency and wavelengths. Wavelengths and frequency relationship is inverse. And also we have another important phenomena which we called it velocity of waves or speed of waves. We showed by c, and normally c is excuse me, c is the relationship between frequency and wavelengths. And for mechanical waves this speed is very low, but for electromagnetic waves they have a very high velocity or high speed, because mechanical waves, as I told you, it's very depends on the environmental conditions. For example, if you change the humidity, the speed of electromagnetic excuse me the speed of mechanical waves will be decreased. But because electromagnetic waves don't need environment, their speed is very high and they have a very high speed. For example, on the top of the page I compared the speed of ultrasound or sound as a mechanical waves, which is just 340 meter per second, compared to electromagnetic waves speed. For example, light is a type of electromagnetic, and the speed is 310 to 8 meter per second, which is about 300 I mean that about 300 million meter per second. For a good estimation, we can say that the speed of electromagnetic over the mechanical waves, or the speed of electromagnetic waves, is 1 million times more than mechanical waves. And I told you this is because electromagnetic waves does not need or does not affected by environmental conditions. Go to slide number 4. Now, in slide number 4, I showed you a, a big view of the electromagnetic waves. Please look at these slides. From left to right, from left to right, the wavelengths will be decreased, but the frequency will be increased. So the first part of electromagnetic wave in the left, we called it radio frequency, and the frequency is wrote under the small blue part, which we called it radio. It's about 10 to 3 hertz, or it's about 1000 hertz. But the wavelength is very it's very long, because I told you when the frequency increase the wavelength is decreased. So when we go to the right of the slides, we will see the wavelengths decreased. For example, gamma ray, which is the last one in the right, has a highest frequency and lowest wavelengths. And also, for a bit better understanding, the cartoons or the very simple schematic which put it on their each section. For example, the radio wavelength is compared to the height of the buildings, or the microwave, which is uh, has a shorter wavelength compared to radio frequency. The wavelength is compared to the height of humans, for example, about 1 meter, 1 meter and a half, 2 meter, or something like that. But when you go to the right, you will see, for example, the second region is infrared, it's shorter wavelength, higher frequency; visible light, shorter wavelengths, higher frequency; ultraviolet, X-ray, and gamma ray. And let me to define or explain them in more details in the second slides, in the five, no, but six, I think. I will return to five. Okay, just keep it at the moment. and go to the slide 6, which I explained you why it's important to talking about wavelengths. And also here the slide number 7, which is again in Persian, but I will explain you word by word and I will translate it word by word in English to you. The first part of the wavelengths is, it was called electromagnetic, excuse me, it was called radio frequency. So the region number 1, it's radio frequency in the wavelengths. But again, please pay attention that when we go to the right of the slide, the frequency will be increased. Can you tell me about the wavelengths? If the frequency will be increased, what happened for wavelengths? Of course. Thank you very much. Of course. Thank you very much. So, we will start with the first region, which I showed by number 1. In the number 1, we have a radio frequency, but the radio frequency, it has a lot of application in medicine, but for my lecture and my course, it doesn't very important, so I don't want to talk about them too much. just just attention to this. In case of radio frequency itself is divided in 4 category. Look at in the below the radio frequency, in below the region number 1, I wrote LW, MW, SW, and FM, which it means that when we want to use radio frequency, normally we want to use the radio frequency to transfer sound. For example, I am in Tehran now at the moment, and I don't know actually what is the distance between Tehran and Kish Island. I'm not sure, but I think it's about 2,000 kilometer. I'm not sure. Probably much or I don't know. The distance is it's I don't know. It's about 2,000 kilometer or 2,000 kilometers, something like that. But I know that I am talking with sound. And I told you in the second slide, the speed of sound is just 340 meter per second. But the distance between Tehran and Kish is about 2,000 kilometer. So how can you hear me? Because the sound speed is just 340 meter, which is very shorter than 2,000 kilometer. So the main reason that you can hear me is we can put the sound on the top of electromagnetic wave. In medicine or in electronic or in physics, when you put one waves on the other waves, which we called it modulation. So modulation, it means put one waves on the top of other waves. So this phenomena called modulation. Now we have a two-way for modulation. First, you can put the amplitude of the waves, sound wave, on the amplitude of the electromagnetic wave, which I will tell you what is amplitude. Okay, this called its amplitude modulation, or we say AM. The second way that you can put sound on the electromagnetic wave is putting the frequency. If you put the frequency of sound on the top of the frequency of electromagnetic wave, it's called frequency modulation, or FM. I'm sure you will I'm sure you have some small radio or on your cell phone or on your home. And this small radio, if you look at the wavelengths, you will see two categories, AM and FM. Now you know that what is AM and what is FM. AM, it means amplitude modulation. It means that you put the amplitude of sound on the top of the amplitude of wavelengths, and by doing this the sound can travel a longer distance, like here from Tehran to Kish. But the second category is FM, which we will see. It means that you can put frequency on the top of frequency of electromagnetic wave, which is they used in I don't know, in a radio frequency area, and they have a lot of application which I don't want to talk with them. But I have a question for you. Look at this figure. On the underline the radio frequency, we have a four category: LW, MW, SW, and FM. Can you tell me the frequency of which one is higher than the other one? Because I told you when we go to the right of the slides, we suppose that the frequency will be increased. So from this, you know that if you go to the right, the frequency will be increased and the wavelengths will be decreased. So between these four, yes, of course, FM, of course, FM, yes. So FM has a highest frequency because in the right, and LW is the lowest frequency because it's in the left. Now, please let to the modulation in this. I think it's enough for now. But just I forgot to tell you what is amplitude. Please, for a few seconds, go to the slide number 2. Yeah, you will see I wrote amplitude. Look at, so the amplitude, it means that the distance between the zero to the peak, to the maximum peak, or the highest of the wavelengths. The height of the wavelengths or the highest point of the wavelength is called amplitude. It's enough for that. Now, return back to the slide number 7. Now we can go to the second region, which is very important. The second region in the electromagnetic waves, this is like a family, this is like a family album for electromagnetic waves because they have a lot of specific regions, okay? So the second region, which is called infrared. So the second region, it's called infrared. And infrared itself divided in three parts, which I wrote it in the bottom of the image. Infrared, it's divided in three parts: F infrared, M infrared, N infrared, or on the other hand, far infrared, medium infrared, and near infrared, which I showed in the image in the bottom of the image. So can you tell me the frequency of which category is higher than the other one? Between FIR, MIR, and NIR, the frequency of which one is higher than the other one? Of course, thank you very much. NIR, because NIR is in the right. And as I told you, when we go to the right, the frequency will be increased. Now, why all the time I ask you this question? Because when we go to the right, furthermore, we will reach to the specific area which I tell you that, oh, dear students, this region is can penetrate inside the cell. This region, it has a shorter wavelength than the space between the head of lipids, and can go inside the cell and damage to DNA and can cause cancer. For this reason, I all the time ask you this question, because I want, my aim is to introduce you this family album, and to teach you and learn you which wavelength is dangerous for us. For this reason, all the time I will ask you these questions. Okay, now what about infrared? The infrared has a lot of application in medicine, treatment, imaging, and also it's very useful technique sometimes for I don't know, for massage therapy or something like that. I will tell you some details about them, okay? Look, first look at the FIR. Just for your comparison, I don't want to ask you to memorize the numbers. Don't worry about the numbers. Just for your imaging, just for your more attention. Look at the some numbers I wrote. For example, FIR wavelengths, it starts from 300 micrometer. It means that the distance between the 2 points is just 310 to minus 6 meter, or 0.003 meter, which is very short. But look at the medium infrared. It start from 20 micrometer to 2 micrometer. It's very short. And again, near infrared wavelengths start from 2 micrometer just to 0.76 micrometer. I want just to show you, when we go to the right, the frequency will be increased, but the wavelengths will be decreased. Now, let me to explain you some application of infrared. The most important application of infrared is for pulse oximeter. Do you know what is pulse oximeter? It's a small device like a glucometer, which is very small. You put your finger in between this device and it can measure the concentration of your blood oxygen, which we called it pulse oximeter. But the pulse oximeter itself work in medium infrared. It means that in pulse oximeter we have two types of lamp. We have two types of diode. One diode is emitter, the other diode is receiver. So when you put your finger in this device, the transmitter lamp or the transmitter diode, which is on the top and which it is a white color. It generates some medium infrared, and these types of medium infrared penetrate inside your finger, and in your finger you have a blood, and in your blood you have a hemoglobin. So hemoglobin would like to absorb a specific wavelength of medium infrared. I think it's about 1 micrometer. The hemoglobin would like it, and it absorb it. For example, if you send, for example, 100 medium infrared, and 80 of them absorbed by hemoglobin, just 20 of them pass through your finger and go inside the receiver. The receiver measure the infrared, and it's know that what was the source, and inside a very small computer, this computer calculates the number of the infrared absorbed by your finger, and on the monitor it shows you the concentration of oxygen is 80. But if you make a sample of blood of the patient and send it to some modern lab, and they can measure the oxygen concentration, the oxygen concentration is very different. It's not very different with the pulse oximeter. I mean that if the pulse oximeter measure the oxygen in concentration just 80, the real concentration of oxygen probably is 75 or 85. So there isn't a big change, big difference between these measurements. But pulse oximeter is very easy, it's very light, it's portable, and it's very useful for measuring the fast oxygen concentration, which you remember during the COVID pandemic, all the people have this kind of pulse oximeter in their home, and they used to measure the oxygen concentration. So this is just one of application of infrared. The other application is, as I told you, if you go to drugstore, you will see some infrared massager. You will see some infrared lamp, which you can use it for I mean that decrease the pain. If you go to gym, and if you have some spasm in your muscles, the infrared can be the best option uh, for for moving or for relaxation of your muscle. So we have a lot of application for infrared in treatment and for diagnostic, for imaging or something like that. And also we have some another application of ultrasound. For example, in military they have a specific ultrasound camera which they can use it for see something at the night. They can see people or animals at the night, during the night. But just for your knowledge, in UK they have a very sensitive infrared camera, and they can detect some cancer cells inside the body, because each cell in our body emitted a specific wavelengths of infrared. Okay, so remember that each cell in our body emitted a specific wavelengths of wavelengths of infrared. For example, the liver produced a specific wavelength, for example, zero point 0.5 micrometer of infrared, and the bladder produced or emitted another wavelength of infrared. If you have a very sensitive infrared camera, you can measure all these wavelengths come out from your body. So probably you can use infrared as a imaging tool. And as I told you, in UK, currently they used infrared for take imaging of women breast instead of X-ray, because X-ray is dangerous, but infrared is not dangerous. Okay, up to now, if you have any question, you can ask me, but otherwise we can go for the next region. Okay, also I want to say hello for the other students which currently joining us. So I will go for the next region, which is the fourth region, and we called it ultraviolet or UV. Okay, again, in the next slide, don't worry and don't panic about the Persian words. I'm sorry, but I will, as I told you, I will translate word by word in English. On the top of the page, again, I showed the electromagnetic family album. In this album, we have specific categories, which will be start from the left with our radio frequency or RF to right with the gamma rays. Okay, I explained radio frequency and I explained infrared, the first and second region. Now I want to talk about the third region, which is called ultraviolet or UV. The fourth region, which is UV, on the top of the page divided again in three category. Can you see that? UVA, UVB, and UVC. This is the three category for ultraviolet again. If you can see that, if it's clear, yes, thank you. Thank you very much for letting me know. Okay, thank you. So again, my question, what is the, I mean that which one has a highest frequency? بله. سلام وقت شما بخیر. در خدمتتون هستم. خیلی متشکرم. میتونم ازتون خواهش کنم که هول هوش ساعت 10 به من زنگ بزنی. الان وسط یک کلاس آنلاینه. سپاسگزارم. خدا. So again, my question, the frequency of which one is highest than the other one? Of course, thank you very much. Thank you. UVC. And now I can tell you from to UVC, it's cancerous. Or on the other hand, the wavelengths or the frequency higher than UVC can go inside the cell and damage to the DNA. Okay, so please remember, up to UVC and the fifth region, which is called X-ray, and the sixth region, which is called gamma ray, are cancerous, are dangerous. Okay, this part is very dangerous. Okay, let me talk about the UV. But before UV, I think I forgot it a region, a very important region to explain you, which is visible light. Okay, I'm sorry about that, but I had a call ringing, and I think I missed one part, which is very important. Sorry about that. So before ultraviolet, we have a very important region, which is the third region, and we called it visible light. You know that visible light is a very applicable in medicine, and you know that from high school, if you put visible light in front of the specific optic lens, the visible light can convert to seven color. Do you know that? Did you hear about that? Which is visible light or white light? It can divided in seven color. Of course, thank you very much. And this seven color will be start from red to ultraviolet. So the visible light, which is the third region, it's in between the infrared and ultraviolet. For this reason, I know these seven color from start from red because it's neighbor of infrared to ultraviolet, which is the neighbor of ultraviolet. But this seven color from the our knowledge, we know that they have a very important application. For example, after my lecture, you can search in Google and just please try to type chromotherapy. Chromotherapy, it means application of different colors in treatment of some diseases. For example, the red color can trigger your nerve system, and sometimes they says that, or in the ancient medicine, they used red color for treatment of specific viral disease. But please pay attention that the red color directly cannot affect of the virus. Just the red color trigger your nerve system, and after that, when your nerve system will be triggered, as immediately after that your immune system will be triggered, and the immune system can attack to the virus. So the red color does not itself effect on the virus, but indirectly it can affect on the virus, and it can decrease a little bit inflammation of the viral disease. But in the other hand, the blue color or green color can make your nerve system calm. For this reason, in the hospitals you will see application of blue and green color. For this reason, sometimes in Chinese medicine we have a chromotherapy, or it means that the application of different color. But again, the visible light, it has a lot of application in medicine. For example, if you put a small visible lamp inside the mouth and esophagus, you can see the inflammation, you can see the tumor, you can see some bacteria infection inside the mouth, inside the esophagus, or inside the stomach. And this process, we called it endoscopy. So the endoscopy, it means application of visible light for see some problems inside the body. And again, if you have a very smaller lump, if you put it inside the I don't know, inside the lung, you can see the problem inside the lung, and we called it bronchoscopy. And also, if you put this visible light inside the lung intestine, we called it colonoscopy. Or if you put the visible light inside the bladder, we called it cystoscopy. So all this process, they are using visible light for see some problem inside the body. And again, you know that we have some laser for cutting the tissue in operation room or for removing some wound or acne on the surface of skin. So these are application of visible light in treatment, because laser, it's a types of visible light. Okay. And also we have another specific treatment method which we called it photodynamic therapy. I don't know if you hear about that, but you can search it itself. Photodynamic therapy, it means that application of visible light for cancer treatment. It works like that: you inject a non-toxic liquid to the patients. This liquid absorbed by tumor cell, not by healthy cell, and after that you irradiate the tumor cell by laser, by specific wavelengths, by specific frequency, and the visible light or the laser light trigger this liquid and it make it toxic. But the liquid just inside the tumor cell and it's killed the tumor cell. So this was the definition of the third region, which we called it visible light. And the fourth region, as I told you, it's called ultraviolet, and it's divided in three categories: UVA, UVB, and UVC. And in case of ultraviolet, on the bottom of the image, I just try to draw a cartoon picture of the sun and the earth, because the source of ultraviolet is on the sun. For example, for UVA, UVB, and UV3, please try to make a note. Just and please try to write a three simple sentence about them. The first sentence is about UVA. I will start with UVA, then we'll continue with UVB, and after that I will continue with UVC. Now, what about UVA? In case of UVA, the source of UVA is the sun. Why this is important for me? Because we have a natural source for UVA, and also we are living on the earth, so the light of the sun reach us. The light of the sun reach to the animal which living with us on the earth. Again, the light of the sun reach to the plants which they are living with us on the earth. And we need animals and plants because we eat them. We need them for keep our body more healthy. For this reason, they are affected with UVA like us. For this reason, UVA is very important for me. Now, what is the main effect of UV? UV can synthesize the cellulose inside the wood or the plants. Okay, so this kind of synthesizes affected to our body, because we are living on the earth and the sunlight can expose to us, can expose to our home, to our house, to our dining room, to bedroom, to our foods, or etc. Okay, so we are affected by ultraviolet A. Again, about ultraviolet B, but before going to ultraviolet B, I want to repeat these three sentences. The first one was introduced by sun, the second was reached on the earth, and the third sentence was the UVA can pass through from the glass window. Why it's important for me? Because it can affect inside our house, for example, our clothes or foods, and or furnish, or I don't know, bedroom or something like that. So these three sentences is very important for all these three category: UVA, UVB, and UVC. The first sentences was it produced in sun. The second was it's reached on the earth, and the third was it can pass through from the window. Now, what about UVB? The UVB again, it has a three sentences the same with UVA. It means that it's produced on sun by sun, it can reach on the earth, and it can pass through from the glass window. Can you tell me what is the difference between UVB and UVA? Yes, of course. The frequency, yes, that's a good answer. The frequency of UVB is higher than the frequency of UVA. So, if UVA can synthesize cellulose in 1 month, UVB can do it in 1 week because it has a higher frequency, and you know that the frequency it means more energy. If the frequency increased, the more energy will be increased, and it can do the everything's faster. Now, what about UVC? Again, for UVC, I should wrote these three sentences, but just the first sentences is the same with these UVA and UVB. It means that it's produced by sun, but UVC cannot reach on the earth because in close of to the sun or in a little bit far from the earth, we have a three oxygen atom, which these three oxygen atom connected together by three spring. But we are lucky because the frequency of this spring is equal to the frequency of UVC. So the UVC produced by sun interact with these three oxygen atom, which we call them ozone. The frequency of ozone is the same with the frequency of UVC, and UVC absorbed by these three oxygen atom, and their frequency will be decreased, and UVA and UVB produced to the earth. So these three oxygen atom can filter UVC or can stop UVC. For this reason, in the second sentences, we will say the UVC does not reach to the earth, and it's a good news for us. Again, the third sentences will be changed because UVC cannot pass through from the glass, cannot pass through from the normal window glass. For this reason, this is a good news also because in the hospital, especially in the infection department, sometimes we have a patient with is resistance to antibiotic. For this reason, the hospital management try to sterilize the room by UVC. So please pay attention that you have a UVC lamp in the hospital, but this lamp is very specific because it's not made from glass, because UVC cannot pass through from the glass. So if you see the UVC lamp in the hospital, please don't make a selfie with that. It's very dangerous. Don't try to look at the UVC lamp, or don't try to touch the UVC lamp because it's really dangerous. Because as I told you in the beginning of these slides, UVC from you know that the frequency higher than UVC, and UVC can pass, it can penetrate inside the cell and can damage to DNA and can cause cancer. I means that if you attach to the UVC lamp, probably by the probably more than 99% the cancer of the skin will be created. Okay, so it's very dangerous. Also inside your microbiology laboratory you have a specific hood which is called laminar hood. Inside the laminar hood, again, you have a UVC lamp for sterilized or for kill some resistance bacteria to antibiotic inside the hood. So please pay attention that in all these in all these types of the hood, they have a normal glass window. Please close it before start the UVC lamp because UVC can leakage or can come out from this apparatus, and it can emit at your skin, and it's very dangerous. And also, I want to just let you something for your knowledge about the normal lamp which we will use it in your house, in your classroom, or other places that you want to make a bright with them. These types of lamp are not dangerous because they made of a normal glass. So I am sure they create some UVA, but their intensity of UVA is very less than the intensity of UVA from the sun, so they are not dangerous. Again, these types of lamp which we will use for our laptop or we will use in our house also produced UVB, but the UVB is just move 1 millimeter from the lamp, so it's not very dangerous. And be sure that they cannot produce UVC because they are made from normal glass, and UVC cannot pass through the normal glass. For transfer the UVC, you need a specific material which we call quartz. It's like a stone. It's like a specific stone which we called it quartz. And UVC lamp are very expensive because they made of quartz, not they made of normal glass. Okay, so this was about UV, and UV it's very important for me because after UVC it's very dangerous and it's cancerous. If you have any question, please let me know and I can go furthermore for the five region. The fifth region is called X-ray, and the sixth region it's called gamma ray. If you have any question, please let me know. Okay, thank you very much. Okay, thank you very much. So I don't want to talk about the fifth and sixth region because my colleagues before me they talked about a lot of things about X-ray and gamma ray. For example, they are using in nuclear medicine, they are using in PET scan, they will be applicable in radiation therapy, I don't know, in brachytherapy or something like that. So I don't want to talk too much about fifth and sixth. And just by up to now, I think the electromagnetic is enough for this lecture. Just the last slides, which I showed here, it's a very important phenomena about UV. Normally, you will go to drugstore and you will buy a cream, a sun protector cream. On the top, on the surface or on the box of the cream, you will see some specific number which is called SPF. And sometimes you will see or you will buy SPF 30 or SPF 50 or SPF 15. What does it mean? Look at the curve. On the Y axis I shows the UV effect in percentage, and on the X axis I shows the SPF. For example, SPF 15, it means that it can filter 93.3% of UV. So just 6.7 percentage of the UV reach your body. Okay, if you use the SPF 30 in your sun protector cream, you will see 96.7 percentage of the UV filtered, and just 3.3 percentage of the UV can reach to your skin. And if you used SPF 50, just 1.7 percentage of the UV can reach to your skin, and 98.3 percentage of the UV can filter. If you ask me which cream is better for buy for you or for use, I cannot answer you because in some specific country they use the specific SPF. For example, if you go to French, the people using SPF 15 because sometimes we need UV for generate vitamin D, you know. So if you block all the UV, probably your body is like a deficiency of vitamin E, which we will see that. But in Australia, they used SPF 50, and in US, they used SPF 30. What it's mean? What does it mean? It means that in some country the O3 or ozone layer it's a very less concentration, so the UVC can penetrate to this area in this country, and the people should protect themselves by higher SPF number. But I don't know about my country, and also I don't know about Kish Island. Probably you have a cell phone at the moment, and after the class you can search on Google. You will see the intensity of UV online, and I mean that there is some application that tell you the intensity of UVA, UVB, or UVC at the moment right now on your area. For example, for me in Tehran and for you on Kish Island. And after that, you know that what is the intensity of UV. But in the first column, which is called SPF1, it means that if you don't use any sun protective factor, probably 100 percentage of UV is reached to your skin, which is not useful. It's not good, especially between 10 a.m. to 4 p.m. Please pay attention that between 10 a.m. and 4 p.m. There is a maximum UVB can reach on the earth, and it can sometimes it can dangerous if you be in front of sunlight for a long time, especially for farmer or specific worker on the road and in desert, when they affected by too much sunlight between 10 and 4 p.m. After a few years, they can feel some skin cancers or something like that because of UVB. As I told you, UVB it's not close to the region like UVC can penetrate inside the cell, but if you be affected by UVB for a long time, for example, for a few years, probably UVB can destroy some part of the DNA inside the cell, and sometimes it can cause skin cancers, which is very important to pay attention to that. Okay, up to now, for the students who joined us recently, I just try to explain you what is the definition of the wave and which kind of waves we have in the world. In briefly, I explained the students we have two types of waves: electromagnetic and mechanical waves. Electromagnetic, it itself divided in seven or six or eight category, which just I talked about five of them, which was most important for me: radio frequency, infrared, visible light, ultraviolet, which they was very important in medicine. And also we have some other category for them like x-ray, gamma ray, or cosmic ray, which it's not related to my subject. And after that I will try to explain each category in more details. And now I want to tell you, in the second lecture, which I will start shortly, I want to switch to mechanical waves because my duty in your lecture is explain ultrasound. So you should know that first ultrasound is a wave. So before that, you should know some knowledge about what is waves. For this reason, I try to explain you this brief introduction. Now we know that we want to talk about ultrasound shortly. Ultrasound is a types of waves, but it's a mechanical waves. It's not electromagnetic waves. So because it's mechanical waves, for propagation it's need medium, and the medium can affect it of ultrasound. So I will switch to start a brief introduction with ultrasound up to 10, and around 10 a.m. I will give you a break about 20 minutes, and after that I will continue with ultrasound. So I want to first I want to to switch, forgot the slide number 10. Just I want to upload another file which it start with ultrasound. And again, if you have any questions, you can ask me. Okay, yeah. Again, I will start with the second lecture, but I have two repeated slides. It's just like a transient slide. Don't worry. Just I want to say, oh, hello, students. This is the second lecture. In the previous lecture, we talked about electromagnetic waves. Then it's categorized for all these regions from the slides, and I don't know if you can record my voice or not. I don't know anything about Skyroom. Do you think you can record my voice? Yes or not? Do you access to my voice or this meeting? Can you record it? Uh, I don't know, but in Skyroom probably you can record it. No? Or can you ask to the administration? Just a minute, please. I will ask the administration that if it's possible for them to